Tangents and normals. Tangent is the straight line with the gradient the same as the curve at that point. Normal is the straight line where the gradient is perpendicular to the gradient at that point. An example, find the equation of the tangent to the curve y equals 3x squared minus 4x plus 1 at the point 2, 5. Find the gradient of this, dy by dx equals 6x minus 4. So at the point 2, we've got a gradient m equals 8. We're looking for the tangent, so that's the gradient we're interested in. We're going to use our equation y minus y1 equals mx minus x1. At the point 2, 5, we get y minus 5 equals 8x minus 2. We're going to expand this out and simplify it at the same time. 8x, 8 times minus 2 is minus 16. Move the 5 across, so we get y equals 8x minus 11. We'll have a look at another example. Find the equation of the normal of y equals x cubed minus 2x squared plus 3x plus 1 at the point 1, 3. So we're going to have to find the gradient, so we'll differentiate 3x squared minus 4x plus 3. At the point x equals 1, we get the tangent gradient 3 minus 4 plus 3 equals 2. So the perpendicular gradient, the normal gradient, is going to be the negative reciprocal of that, so it's minus 1 over 2, so it's negative a half. We're going to use our formula y minus y1 equals mx minus x1 to get y minus 3 equals minus a half x minus 1. Don't like the 2, so I'm going to move it across to the other side. 2y minus 6 equals minus x plus 1, expanding out that bracket. We'll rejiggle it to make everything positive. 2y plus x equals 7. Another example here. Find the normal to y equals x squared minus x at the point 2, 2. We'll find the gradient of it, differentiate, we get dy by dx equals 2x minus 1. So that gives us a tangent gradient at the point x equals 2 of 3. Gives us perpendicular a normal gradient of minus a third. At the point 2, 2, we're going to do y minus 2 equals minus a third x minus 2. Move the 3 across, expand out the bracket, we get 3y minus 6 equals minus x plus 2. And rejiggling it, we get 3y plus x equals 8. In this next part, I want to find the coordinates of the point where it hits the curve again. So I want to know where that normal hits that curve, y equals x squared plus x, again. I've got two lines that are intersecting. I'm going to need to use simultaneous equations. Easiest simultaneous equations to do when you've got a linear and a quadratic is substitution. So we'll take the 3y plus x equals 8, we'll reform it into x equals 8 minus 3y. We're going to substitute this into our quadratic. That gives us y equals 8 minus 3y all squared minus 8 minus 3y. Expanding out that bracket, you can either write it out twice if it helps. You get y equals 64 minus 48y plus 9y squared. Expanding out that other bracket, we get minus 8 plus 3y. Collecting all your like terms, putting everything onto the same side, setting equal to 0. We get 9y squared minus 46y plus 56 equals 0. Nothing we can do to simplify that, so we're going to factorise it. We can factorise that. We know from our original coordinate that one of the solutions was 2. So I've got 9y minus 28, y minus 2. The y minus 2 is the solution I already know, so the other one is the one I'm interested in. Y equals 28 over 9. That's only the y coordinate. I need the x one as well. So I'm going to sub it back into this equation that I created. I get x equals 8 minus 3 lots of 28 over 9. So that's the same as 28 over 3. 8 is the same as 24 over 3, so that gives me minus 4 over 3. So my coordinate is minus 4 over 3, 28 over 9. Thank you.